folks, it's me, Professor Bizarre, coming to you live from Brooklyn, New York. If you are at Fordham University, I am so sorry that I was not able to come to class today. You gotta love the MTA, am I right? Anyway, yeah, I really apologize for not being able to make it in today. I would love to stay on course, though, with the sort of trajectory for what we're trying to accomplish in the course. And so what that means is that we really want to start diving into learning how to use these digital tools that are going to help us in our game design practice. Notably, we're going to talk today about how to use GitHub and Git, the software and website where the class syllabus is held. And I'm also going to show you how to use I'm going to get you acquainted with the sort of general ideas behind the Godot game engine, and I'm going to sort of point you in the right direction to start learning that. Okay, and we're going to pick all of that up back in class on Friday, probably. Maybe we'll get to it on Tuesday if we finish the gameplay testing, but if not, we'll pick this up on Friday. So the goal here is to sort of supplement and fill in for this gap in time where we're meant to be kicking things off, right? We really want to start kicking off digital game development next week. So hopefully you can watch this video and sort of follow along, and we can still be on track to do the lab assignments and start working on our 2D games, okay? And that might sound like a lot, right? We haven't even touched any digital game design tools yet, but in truth, some of the best ways to actually learn digital game design and development is through video tutorials, because you can pause and rewind and stop and start. So I hope that this will be an invaluable resource in getting you oriented with some of the groundwork of the things we need to cover going forward. But if not, please reach out, right? You have my email, you know how to get in touch with me, and we can really get things sorted out, okay? So, with that being said, I'm going to be doing this primarily live, so please forgive me for kind of fumbling through some edits, right? It's not going to be the most cleanly polished video, but I do hope for it to be comprehensive, okay? So the goal for today is to get us acquainted with, again, GitHub and Git Desktop, the application, and also the Godot game engine, okay? So I'm going to turn myself off. Okay, so you should see my screen now, and you should also see this web page, right? This web page is the Lab 1 assignment, okay? This is in our syllabus. This is the first sort of next piece of work we're going to be doing in our class. In Lab 1, what we want to do is, I'll link to a template that you can use to complete the following. But what we really want is we want a 2D Godot project that has a main scene, 2 different sprites or images, okay, several instances of another scene, and then we want a GitHub repository with the project inside it and a README where you describe the project and write out any questions or things that you learned along the way. Okay, whoa, what is all that? That sounds kind of like a lot, right? But again, the point of this video is to sort of walk you through all the steps you need to do in order to create that, okay? I do have a pre-recorded chunk sort of going through Git initialization, which I'll probably cut to here, okay? So I'm going to just insert a cut. I'm going to show you how to work with GitHub to be able to save your projects onto the internet and to download other people's projects from the internet. GitHub is a code hosting platform where all sorts of different code and projects are shared by developers around the world, and it's a great way to work with your code both with other people, and it's a great way for you to share your project between different devices. If you're working on a laptop at home or computers at school, it's a great way to be able to ensure that you have the same version of your project saved on a bunch of different platforms. So I'm going to show you the basics of how to get up and running in GitHub. So if you come to GitHub for the first time and you don't have an account, you might get a page that looks a little bit like this. You're going to want to go over here to sign up, okay? You're going to get this nice little prompt. I'm going to enter in my email. Okay, and continue. I'm going to create a password, which you are not going to see. Once you create a password, you then enter in a username. I'm going to go ahead and hit continue. I hate product updates, so I'm not going to get any of those. And then you have to verify your account, okay? So I guess GitHub wants me to solve a little puzzle. And it's pretty confusing. Use the arrows to rotate the object to face in the direction of the hand. Cool. That seems good to me. Submit. Great, I'm glad I'm not a robot. I was worried for a minute. So now I'm going to go ahead and create my account. Okay. And of course, you're going to have to verify your info. Okay, so I'm going to go ahead and do that. 587-926-68. 587-926-68. 587-926-68. Okay. And then, oh my God, I'm getting blasted off into the future. Why is this happening? That's wild. That's a wild choice for software, but here we are. Here we are in GitHub, okay? And so now you sort of have this whole dashboard that looks a little bit overwhelming. You can just close any pop-ups that you don't want to see. So the way GitHub works is you have a profile, and on your profile you can have repositories, okay? What do I mean by that? Here's my profile, JBzark. I'm going to go to my profile, and you'll see that there is sort of a history of me and all my stuff. And when I have repositories, you'll see them appear over here, okay? If I click on this tab up here, I can go to repositories. You'll see that I don't have any public repositories. Let's change that. I'm going to create a new repository, okay? And a repository is sort of like a project. It's a bucket of code, of documents, of whatever you want. You can have anything hosted on GitHub. It's really just a way to organize files and share them on the internet. So I'm going to click New, and I'm going to make a new repository. I'm going to call this intro Godot GitHub repo. Repo is short for repository, and I can add a description, an introduction to Godot and GitHub. And you can decide whether or not you want your code to be public or private. For this course, I recommend keeping your code public, at least while we're in class. It's much easier to share your code when it's public. If you're really passionate, though, about protecting your code and keeping it private, you can make it private. You'll then just have to share it. You'll have to invite me or other class members to the projects specifically. But again, if that sounds a little complicated, it's easiest to just keep things public, okay? So I'm going to make a public repository, and I'm going to just go ahead. You don't need to, you can add a README file. A README file is just a sort of a blank markdown document where you can sort of add information to your project. And I'm going to go ahead and give a, these are the copyright licenses that you can give to your files, and it's worth it to dig through those at your own leisure. But the MIT license is a pretty nice, good open source license. Okay, so I'm going to go ahead and then hit Create Repository. And you'll see that I now have this repository created, okay? And it has a license, the license that we added. You can open up the license and read it, okay? This is the text of the license itself. It also has this README file in it, which has the title of the repository and the description that we wrote in. And if you want to edit this file, you can just click on this little pencil up here to edit this file. And I can add some text to it, okay? So I'll say, wow, cool text. And then I'm going to commit changes. Now in GitHub and in Git, you always need to save your work and then commit those changes to the repository. Commit them to the Git history. Okay, so in order to do that, you click on commit. And you often need to have a Git message where you describe what you've changed. So I updated the README. And you can add some even more text if you want. I'll say, I wrote a nice sentence. And this might seem like overkill if you're just doing this, you know, to goof around in the way I am, but it's really helpful when you're collaborating with other people, or even if you're working on something that you're just working on by yourself, but you're doing, you know, a very large project that's taking a long time. It's really nice to write these little messages and descriptions because you can always go back and look at all of the changes you made in the past And having a little bit of a title and a description of what you did helps you remember, or helps your collaborators understand the edits that you've made to your code or to your repository. Okay, so I'm going to go ahead and hit commit changes. We'll talk about branches later in this series, but for now we're just going to commit directly to the main branch. Okay, so I'm going to hit commit changes. And you'll see now at the base of our project, right, you'll see this README, we have updated this file to include the sentence that we just did, okay? Now that's pretty cool. That's a pretty good way to edit text and things online, but let's try and figure out now how to actually like add some real files and add some real code to this repository so we can actually share our Godot projects, for instance. The best way to do that is to use the GitHub desktop app. Okay, so I'm going to search for GitHub desktop, and you'll see that it comes right up when you Google it. I'm going to click on it, and then I'm going to download the version that's right here. Okay, if you're on Windows, this will pull up Windows. If you're on Mac, it'll pull up Mac. And then once you're ready, you can just once you've downloaded and installed that app, you can just launch it. And it'll prompt you to sign in with your account info. Okay, so I'm going to go ahead and do sign in. The easiest way to do it is to sign in with the browser. Okay, so I'm going to go ahead and continue with browser. And then it's asking me to authorize this desktop app. I'm going to go ahead and hit authorize. That sounds good to me. And then if everything goes smoothly, it should just automatically sign you into your account. Okay? So now that you're kind of oriented with GitHub and the way we create repositories and stuff, I'm going to go ahead and create a repository for Lab 1. And then I'm going to show you how to upload that repository to GitHub. And then I'm going to show you how to create a Godot project. Okay? So again, the best way to interact with with GitHub, there's two major components, right? There's the website, the GitHub website, and then there's the GitHub desktop app, which you should all hopefully have installed by now. And the GitHub desktop app is really an excellent way to interact with Git and GitHub. Okay, so what I'm going to do is I'm going to open up that application, GitHub. Okay, and I'm using, it's worth it to note, I'm using a Linux computer right now, so it might look a little bit different from your computer, but this application should look the same on whatever desktop you're using, and it works the same way. Okay, so what you want to do in order to create a new repository is you click on File and just click on New Repository. Okay, and we're going to pull up this dialog to create a repository for the labs. Now you can create multiple repositories for each lab. What I actually recommend is just creating one repository for all of your lab assignments. And then you can just update it, and you don't have to go through this process every single time. So I'm going to do like a demo of that now. Okay, so I'm going to say like John Bizark's I'll say John Bizark Labs. Okay, a description, a repository, a repo containing all my lab assignments. Pretty neat. Then you're going to pick a path. Okay, the path is where on your computer you want to save this repository. Okay, so I'm going to hit choose, and I'm just going to go ahead and save it to my home folder. Okay, this is just like the, I'll save it to my documents. There's less stuff in here. I'm just going to save it to this folder called Documents. Again, you want to save it somewhere that looks good to you, where you typically store all your files in your computer. That would be a good place to save this this file, right? Somewhere you're going to remember, okay? It is important to know where this directory is on your computer. So I'm going to hit select, and you're going to see that it says home John B / documents, right? That's the path. I am going to initialize this repository with a README, since that's part of the assignment prompt. Then I'm going to go down, and I'm going to find the Godot or Godot ignore files. Okay, so if I click this, this is just going to tell GitHub, hey, you should not pay attention to some specific Godot files, right? All sorts of programs have basically secret files that they use to sort of store different types of like information about like the state of the program that aren't actually necessary to your project, right? So it might be things like which window did you have open, or basically sort of information that's only really important for you using this project on your computer, okay? All different types of programs do that. And by telling GitHub what sort of program you're using or what sort of language you're using, GitHub will know to ignore some of those files that aren't necessary for synchronizing, okay? And then finally, I'm going to go ahead and give this a license. A nice, open, generous license is the MIT license. You don't have to give it a license, but this sort of is just a nice way to kind of let the internet know what the legality is for them using and interacting with your code, okay? I'll show you the MIT license in a minute. So I'm going to go ahead and hit Create Repository. And what we'll see now is, well, nothing really happened, but if you click Show in your file manager, right, we'll see now we have here in my home folder, in my Documents folder, you should see that we have this new folder that I just created, okay? And I'm going to open it up. You'll see a couple different things. You'll see the Git ignore files and the Git attributes, right? You might see these dot folders. You might not see dot folders. Again, dot files are sort of like secret files, so if you don't have them turned on, you don't see them. It's not really important. What is sort of notable is that we have this license that we created, right? So if we open that up, you'll see that here's the MIT license, which gives you sort of free reign to do whatever you want with code. I'm fine with that. That's just the pre-generated license that we selected. You'll also see that we have this README file, right? So if I open up this README file, you'll see that here's like the text file of the markdown of the README, right? README is like a file that you use to sort of describe the contents of any sort of folder or software that you're interacting with, okay? And the last thing I'm going to do is I'm going to show you what it looks like on the internet, right? So this is all currently locally on my computer. So we created a repository locally on my computer with Git, and now we're going to put it online onto GitHub, right? Again, there's a distinction between Git, which is sort of like this version control program that runs locally on your computer, and then there's GitHub, which is sort of like Facebook for code. It's like a website where you can put your Git repositories so you can share them with other people. So again, currently this repository is just on my computer. You can't see it. But in order to put it on the internet and to share it with people, you have to click this blue button, Publish Repository. So I'm going to hit Publish Repository, and it's going to give me a couple more dialogues to step through, right? It's going to ask me, what do I want the name of the repository to be on GitHub? I'll keep it the same. I'll keep the same description. This is an important one. You're going to want to tick this, untick this, so you can make the code public, okay? So I'm going to make the code public, and then I'm going to publish the repository, all right? And bing, bang, boom, it has been published up to the internet, right? And so now if we click View on GitHub, you'll see that here on GitHub, here's this repository, right? And again, a repository really just is a folder of files. It's like it's a collection of files that you're sharing, okay? So all of the files that you see here in this list, you will also see them here in your file manager, okay? There's no difference between the two. And when you clone a repository, right, when you copy a repository, you just download those files. As a matter of fact, I think it's probably important to show you how to clone the repository of this syllabus, of the syllabus for our class, right? Because there's actually a lot of code and helpful examples in the syllabus already that you're going to probably want to have access to. So if you go to the syllabus, if you go to my GitHub page and then to the syllabus, I teach at a couple different schools, so if you're at SVA and you're watching this, you can just go to the SVA syllabus. But if you're at Fordham, go to the Fordham syllabus. And then if you want to get access to the syllabus, you can do a couple different things. The easiest way to get access to it is to just download it as a zip file, okay? This is good in the short run, but it's not good in the long run, okay? So I'm going to show you how to do it in the short run, and then I'll also show you how to get access to it in the long run. But if you just, if you need a quick example really quickly and you're maybe on a new computer or something and you don't want to actually go through the steps of setting it up fully on your computer, you can just click download zip and it's going to download a zip file of the syllabus. Now it's going to take a second because there's actually a lot of stuff in here, particularly in this resources folder. There's like a bunch of other projects and files and things, so it might take a minute for it to download. But there it is, it's done. So I'm going to open it now, and you'll see here it is, right? This is just a folder of files. So we have these files, and I wonder if you can see that. What I'll do is I'll extract it to my downloads folder. There we go, we unzipped it, right? So here's this folder, And then here are these files. Here's the README file for this. Whenever I go to GitHub in class, this is the actual text file that we see on the main page. We also have these resources, right? And we have all of these files and folders of projects and different things that you can use to create different examples you can use to sort of see what I'm doing, right? And when you sort of download the zip file of a GitHub repository like this, it's really good for a one-time thing, right? But what's really nice about GitHub in general is if you do go through the steps of cloning a repository and staying in sync with it, you can actually get updates to it, right? This zip file is just a set of files that you've downloaded off the internet one time. So if I make any changes to the syllabus, these files in your computer are not going to change, right? They're just they're static things that you already got in the past. But if you want to sort of stay in sync with a GitHub repository, you're going to want to go one step further and clone the repository. So in order to clone a repository, all you need to do is hit this code button, and then you have a couple different options. You might have a button that says Open in GitHub Desktop. You can click that. Another really easy way to clone the repository is to just click this Copy URL to Clipboard button, okay? Then I'm going to go to the GitHub Desktop app. I'm going to go to File, Clone Repository, and then I'm going to click URL, and I'm going to paste in this URL. And then you're going to want to pick a path to clone it to. I'm also just going to clone this to my desktop, or to my documents folder. That's fine. And then I'm going to hit clone. Okay. And it's going to take a second to clone, because again, it's pretty big. Almost there. Okay, and now we have the repository cloned. Okay, so now we've copied a repository, right? So I've just shown you how to create a repository and how to clone a repository. And the great thing about cloning repositories is that you can receive changes to those repositories. So if I go into the syllabus and I change something or I add a new example, you can fetch the example. I'll show you how to do that in just a second. So an example, right? Let's say I change the syllabus. So here I am on GitHub. I'm just going to edit the main syllabus and say, like, I'm going to add a new thing saying, please watch the video tutorial on GitHub and Godot. Okay. I don't have the link to that yet because I'm still recording the video, obviously, but I'll just put this text in here for now. And then I'm going to commit the changes. And I'm going to update it. So this is me, the professor, updating the syllabus, right? And so now we see on the syllabus itself, up on GitHub, you'll see that we have a new piece of text here, right? We have this new text. Back down on my computer, on my local computer, in the syllabus that I just cloned, you'll notice if I open up the text file, we don't have that new change yet, right? We still just have this this first chunk. That's because the whole point of GitHub is it's like a better Google Drive, right? Google Drive or Dropbox or any of these syncing services, they take care of file conflicts automatically. What does that mean, right? Let's say the two of us are working on a project and I edit like a file on one computer and you edit a file on another computer, Google Drive is going to just try and do its best to figure out which version is the most recent version. Okay, that might be okay if we're doing something like writing a paper together or making a poster or something, but in coding, it's actually really important that we keep a distinction between different versions, right? If we just are kind of arbitrarily combining things together, that can break our code really easily. And so what GitHub does is it slows down the process of synchronizing files together. So in order to synchronize anything, you have to manually check to make sure that you're ready to synchronize it, okay? So let's say I, the professor, have just updated the syllabus, and you, the student, want to fetch the recent version of the syllabus, right? Let's say you want to synchronize and get these changes. What you do is go to the GitHub Desktop app, go to the repository. So if you're in a different repository, right? Let's say you're in your lab repository, you want to switch to the syllabus repository. okay, then you want to see if there's any new updates. And you'll see up here that at this pull origin tab, we have an update that we can pull down off the internet to see to implement as a change, right? So in order to do that, all you got to do is click pull up origin, and we have just fetched the latest version from the internet, right? And so if I open this in my file browser now, you'll see if I open the syllabus, now we have this new line of text, right? So again, in order to get changes from a repository on the internet, you need to, you want to clone the repository, and then you want to fetch those changes, all right? And I really recommend doing this with the syllabus in particular, because that way, you know, at the end of every class, as I go through teaching you coding, I'm going to be creating a lot of examples in code, and if you clone the repository for the syllabus, then you can fetch those changes and have those examples on your computer yourself, so you can work with them and modify them, okay? So that's cloning repositories in a nutshell. Now let's switch back to the lab repository, right? This new repository that we just created for our homework. And I'm going to show you how to make a Godot project and work within it, okay? Again, here we are looking at the lab 1 requirement. We have already created a GitHub repository, which is great. And in order to turn this lab in, all you really need to do is go grab the URL for this lab, just copy it, and submit this on Blackboard, okay? You just need to paste this into Blackboard, and I should be able to get the lab, okay? So we're pretty good, but again, though, you know, it's not just an empty repository that we want to turn in for our homework, right? We need to create a Godot project that has a 2D scene, a main scene, several instances of another scene, and a couple different sprites, okay? So let's start doing that now, right? So if we open up this file manager, we'll see that we have a pretty empty folder. Let's change that. Let's create a new Godot project. So in order to create a Godot project, the first thing you're going to need is Godot, right? You can find Godot at the at GodotEngine.org, okay? All you got to do is go to this website and click Download Latest, and then it'll prompt you to download it for whatever platform you have. Okay, again, I'm on Linux, but if you're on Mac, you'll see a Mac icon here. If you're on Windows, you'll have a window icon. And what you're going to want to download is the 4.3 latest version. Okay, again, if you're interested in using C#, you certainly can. I'm not going to teach you C#, and if you don't know what C# is, you don't need it. You frankly can get by with using the internal scripting language GDScript to do everything that C# can, okay? And I think GDScript is a lot more approachable than C# anyway. So if I were you, just click this button and you'll start downloading the project, okay? You can donate if you want. And then just install it like you would install any other program, okay? Once you have it installed, you should be able to open it up, and you should see something that looks a little bit like this, okay? You won't see anything in here, right, because you shouldn't have any projects. You'll probably see some text that says, like, create your first project or something. But otherwise, you should see things that look exactly like this, okay? You'll see up here on the left, we have a create button. This is how you create a new project. You have your import button. This is how you import existing projects. You can also search for projects by sort of scanning a folder, okay? So you can sort of look for a folder on your computer. So if you want to import any of the syllabus projects, you can do it that way. You can also check out projects made by the community, demo projects in the asset library. And if you want to do that, you just click on this big button at the top, asset library, and you should see a bunch of demo projects. And again, something that's really wonderful about the Godot community is it's an open source game engine, which means that all the source code to the game engine itself is freely available on the internet for you to modify and create. And the Godot community also has that ethos. So all of these projects are free for you to use and interact with. There's a lot of good like starter kits for assets or templates for projects. So if you're trying to figure out how to get started, you can check out the asset library. If you click on Asset Library and you can't see anything, you might see something that says like you need to enable online mode. You should be able to click a button. If not, you can also go to Settings up here and go to Network Mode and click Online. Okay, so just make sure this online mode is turned on. Okay, you can also change the size of the engine if you want. So if you want it to be smaller, you can change it to smaller. If you want to change it to bigger, you can change it to bigger. I'm going to leave it the way it is because I think it looks pretty good. Yeah, that's how you can change specific components of the engine. Okay, you can also change the theme right here. So if you want to make it dark theme, you can change it to dark theme. You can change it to the default mode. You can change it to a light mode. Okay, I'm going to change it back to my custom. Oh, my presets, my custom mode is gone. That's okay. I'll just go back to default then. Maybe I'll do Godot 2. It's kind of ugly. All right, back to default it is. You can also change the language of the editor. Okay, so if you're more fluent in another language and you'd rather read the text of the editor in a different language, you can easily do that, right? Let's say we want it to be in German. You can change everything to German, and you would need to restart the editor in order to do that. I'm not going to change it to German though, because I'm not fluent in German. I'm going to go back to the Projects tab, and I'm going to go ahead and create a brand new project. Okay. So I'm going to click on the top left over here, and it's going to open up this new project dialog. Okay, in this new project dialog, the first thing you're going to want to do is name your project. Okay, so I'm going to call this like Lab 1. Okay, and you're going to want to put this in a folder, and this part is particularly important. You need to put it in the folder that is your GitHub repository. Okay, you're not going to be able to upload your project unless it is in the folder where that is your repository. Okay, so for instance, right, this repository is located. You can always find out where your repository is by clicking Show in File Manager. Right, this particular repository is located in my home/documents/John Bizark Labs. Okay, so over here in Godot, I need to go to Browse, and then I need to go to my home folder, which is right here. And where is my documents? Right, home, documents, and then John Bizark Labs, right? So this is the folder, and you'll see, right, here's the README file and the license. There's the README file and the license. So I'm going to select this current folder to be the parent directory for my Godot project. Okay, so again, it's really important that your Godot projects be inside your repository folder. Okay, so I hit select current folder. And you're going to see now it says we're going to create this path, right? We're going to create a folder called Lab1 inside John Bizark Labs, inside Documents, inside me, inside Home. Okay, so that's good. That all looks good. The final couple of things are you get to select which renderer you want to use. You don't need to worry about this too much right now, but briefly to describe the difference between the three of them, Forward Plus is the most advanced 3D graphics renderer out there for Godot. Okay, so it supports really high-end, high-resolution, very sort of advanced graphics. However, when you publish your projects, you can only publish it to desktop devices, to computers or potentially consoles. Okay, mobile is sort of the mid-tier, and it works really well, and it also supports publishing to phones and mobile devices. Compatibility is the lowest end, so it ostensibly looks a little bit worse than some of the other modes. Again, with simple stuff, you can't really tell the difference. But with very complicated 3D scenes, it might not look as pretty. But it is the fastest renderer, and you can export your projects and publish them on the web. Okay. For our purposes, everything we're doing today is very straightforward, and I really like being able to publish things onto the web itself, so I'm going to select the compatibility renderer. Okay. You can leave the version control metadata as Git. Again, that's going to just make sure that the project works with GitHub and Git. And so all of these settings look pretty good, so I'm going to go ahead and hit create and edit. Okay, and you'll notice a couple things happen kind of quickly. Firstly, in the folder itself, right, in this project folder, you'll see we created this Lab1 folder in my Labs project. And you'll see we have a bunch of Godot stuff that got created kind of automatically, okay? And here in Godot, you'll see that we've opened up our first Godot project. It's so exciting. Wow, it's a blank canvas. We can do anything we want. But before we start doing anything we want, I want to get you oriented to the whole sort of layout and world of Godot. Okay? So the Godot game engine is a 2D and 3D and VR and AR game engine. You can use it to create web games, desktop games, mobile games, console games, and XR games. Okay? fundamentally, the thing that you're looking at right now is the editor, and it has sort of four major areas that are worth noting. Okay, there's this panel up here in the top left, the scene tree panel. You have this panel down here in the bottom left, the file system panel. Okay, you have the inspector over here on the right. Okay, and then you also have your main viewport right here in the center. All right, these are sort of four fundamental areas of the editor, and we're going to go over each of them today. Okay. So let's start with this big one, okay? So as tempting as it might be to start playing around in the 3D editor, we're not going to do that today. It's tragic. We're going to switch to the 2D view. But actually what's notable about this is right here at the top, you'll see that there are these four big buttons. These control the contents of your main viewport. So we have a 2D view for 2D projects, a 3D view for 3D projects or 3D scenes. We have a script tab, which is where our code editor will be when we start doing coding. And then we have another asset library where, again, we can see even more plugins and tools and assets that we can use in our projects that are made by the Godot community. And again, it's huge, right? There's like, let's see, let's go to the last. There's like 37 pages now of 3 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 times 9 is 27. So there's like, 27 times 37 plugins and things that you can poke through and explore. So there's a lot of stuff in the asset library. But I wouldn't even start there. That's sort of adding a whole bunch of extra stuff on top of the engine. Let's just learn the basics on the engine right now. So I'm going to switch back to the 2D mode. And you'll see here we have this 2D, this two-dimensional view of a place, right? Of a space. It's kind of like a big canvas. And you'll notice a couple things right away, right? We have this green line going up and down. We have this red line going left and right, and it kind of turns pink in the middle here. That's because you can see very faintly there's this blue line, this blue square, kind of going all the way around here, okay? This blue square describes the edges of the screen, okay? When we run our game, this blue line is going to show you what's in the frame of the game and what's out of the frame of the game, okay? So we have this blue line that shows the window, okay? And you can move around this space, this 2D space, by, if you have a mouse with a middle mouse button, you can press down on the middle mouse button and drag. That's one way to do it. If you don't have a mouse with a middle mouse button, I recommend switching to this pan mode up here. You can either click on this or you can press G, and then you can just click and drag with your regular mouse, okay? And you'll also notice up here, right, there's a bunch of different little icons and things that we can use to help us navigate. Okay, so currently we're in the pan mode, but if I want to go back to the select mode, you can click Q to do that, or you can click this button. You can press Q, or you can click this button. And you'll see that we can, it has all these different sort of like extra actions you can do when you're in this mode. Okay, you don't need to worry about that now, but it's helpful to know that they're there. Okay, so when we're back in our regular select mode, we can't really navigate, but it's very easy to select things. Okay, but let's just get back to sort of understanding how to navigate this canvas, right? So you can also drag these bars at the bottom, right? Up, down, left, or right. If you can scroll, you can zoom in and out. Okay, so scrolling out zooms out, scrolling in zooms in. If you hold Control and scroll, or perhaps on Mac it's Command and scroll, that'll scroll you up and down. And then if you hold Command and Shift or Control and Shift and scroll, that'll pan you left and right. Okay, so those are different ways to navigate. And it can kind of be confusing to tell how zoomed in or zoomed out you are, particularly when you don't have anything on screen. One easy way to tell that is by looking up here at the top left. You can see that we have this number, this percentage, that sort of shows you the scale of the viewport currently. And if you want to reset it, you can just click it, and it'll zoom it out to 100%. Okay. You will also know, and you can also click over here to center the view. That's nice. And this centering the view is very interesting, right? Because it centers us right here on this plus sign, where we have this green line intersecting with this red line. This intersection right here is called the origin. Okay, and you can think of the origin a lot like a graph in algebra class, where you have your x-axis, which runs left to right, and your y-axis, which runs up and down. And you'll see here at the top of the screen, you can even see numbers, right? So this is 0 is our x-axis, and 0 or on our y-axis, and then 0 on our x-axis over here. So this position right here is what's known as 0, 0, right? The only difference, so it works very similar to math class, where if you go to the right, you increase, and if you go to the left, you decrease. However, it's important to know that in computer graphics, that y-axis is actually upside down. So if you're at the origin and you go down, you can see over here, these numbers are actually increasing. So this is 0, 0, and this over here is like 250. I'm going to actually click on the ruler mode to show you that. Right, so if I drag down here, you'll see that this number is increasing. But if I drag up, well, you'll also see that it's increasing because it's just measuring the distance. But you can see over here, right, this side number is 250 negative, and this number over here is 250 positive. Okay, I'm getting a little bit in the weeds here on positions and stuff, and it would be really a lot more helpful to help you understand this if you could actually see something on the screen and we can kind of move it around. So let's go ahead and add our first node to our scene, okay? Something I'm going to do very quickly is just add an icon to our screen, an image. And Godot has this built-in little icon. It's very cute, very easy to use. All you have to do is take this file from the file system and drag it onto the screen. Okay, I'm going to drag it and drop it, and bang, a couple things are going to happen. Firstly, you're going to see it now suddenly on your screen. You're also going to see up here that the root node of our scene just got filled in. Wow, root node of scenes. Okay, what does any of that mean? Godot organizes everything fundamentally in scenes. And a scene is just a list of different nodes. You can think of nodes like Legos or building blocks, and you combine different nodes together to create scenes. And you combine scenes together to create projects or games, right? So you can kind of think of it like nodes are inside of scenes, and scenes make up games. Okay, so before we added this node to our scene, we didn't have anything here, right? I'm going to delete it again, and it looked like this, and it's saying, hey, you can create a root node for your scene. Every scene needs a root node, right? But by dragging this node, this file into the scene, we actually just created a new node right here, okay? And this particular node is called a sprite 2D. Okay, you can see the name of it over here in the inspector. And it has a property called texture, and that texture is this image file. Okay, that might be a little bit confusing, but all you need to know about the sprite 2D is it basically just draws a picture on the screen. So it can take any sprite 2D can have a picture or a texture. It can also have a position, which you can see inside of the transform property. Okay, and the position is a number. It's a vector. It's a two-component number, so it has an x position and a y position, right? And just by dragging this picture around the screen, you can kind of begin to see what I mean by these numbers, the way this coordinate system works, right? If we drag it right to the center here, you'll see that it's basically at 0, 0, right? And if I drag it over here to the right, you'll see that the y position stays the same, but the x values increases. If I drag it over here to the left, you'll see that the x goes negative. If I drag it up here, again, you'll start to see that we have a negative number, okay? And if I drag it down here, we have a positive number. Why is that? Well, you can kind of think of it like, you know, the screen, the video game screen is here. It's this rectangle. And the way that old computer graphics used to work is they would actually draw them out from the top, line by line, almost like a book, right? You're reading a book. So because of that tradition, computer graphics are still rendered in the way where positive numbers go down and negative numbers go up. Okay, so you always think of it like you're starting at the top left, and in order to increase, you can go down and to the right. Okay, so if I go all the way down to the right over here, you'll see that we have like 1,000 over here. And if I go all the way to the left over here, we have like a smaller number. Let's say I want to create this at a very specific number. What you can actually do is you can go over to these numbers. Let's say you want to adjust it very subtly, like maybe instead of at 158, I want it to be 150. you can click in here and you can type in numbers, right? So I can type in 150, and then you can hit either enter to like exit out of it, or if you want to go to the next field, you can press tab to go to the next field, and then you can type in a number here. So this is very helpful if you want to do a subtle adjustment to your numbers, right? Or if you want to do a big adjustment, you don't want to drag it, right? Maybe I want it to be like 400, right? So you can change things just by entering these numbers over here. And you'll also see that this, well, for starters, if I click away from it, right? If I click off of the node, everything disappeared over here. Why is that? Well, because you have to have a node selected in order to edit its properties, okay? Selecting a node you can either do by clicking on it in the tree, or you can click on it in the scene. And when you do so, then we sort of pull in all of these properties that refer to this specific node, okay? So as I was saying, right, if we want to if we want to reset any specific property, you can just click this little arrow button and it'll reset it to its default value. Okay, now I'm already sort of throwing around a lot of words. I'm throwing around words like property and node and scene and all this. A property is just kind of like a, it's like a property. A property is sort of like a thing that a node has. You can think of nodes sort of like nouns in a sentence, and a property is kind of like an adjective. Okay, so like maybe you have a dog, right? But you can also have a big dog or a small dog, or you can have a blue dog or a red dog, right? Properties are a lot like adjectives, and nodes are like nouns. So like this icon, right? This is an object. This is a noun. It's a thing. And we can have a property that is a position. It can also have a property that's a rotation, right? So you can change its rotation. You can drag it around. It can also have a scale property, which you can either change by changing this number, or you can change it by dragging this little thing. Now you'll notice that when you drag it, right, when you drag it in the corner, it gets all, you can sort of squish it in a weird way, and that might be what you want to make. That's totally fine. But if you don't want it to be squished when you're dragging things, what you can do is you can hold, I believe, Control, nope, maybe Shift. You can hold Shift to drag, and it'll keep the aspect ratio the same. You can also, over here in the text field, type a number, right? And you'll notice that by default, it actually doesn't want you to unlink the scale, because it, that typically looks weird when we do that. So you'll see that there's this sort of like chain link symbol here. This means that these two numbers are linked together. So if I make this 20, you'll see that that one turns into 20. Or if I make this like 10, that turns into 10. If you do want to unlink it, all you have to do is click this unlock button, and then you can make whatever you want. So, yeah, so this icon, right, this icon has a position property, it has a rotation property, it has a scale property, it also has a skew property that's kind of like slanting it. And it also has a bunch of other properties, right? Every node has all of these properties, and you can kind of open up these drop-down menus to see all the different properties that this node has. And you don't need to know all of these properties all at once, right? We're diving into Godot head first, and there's a lot to learn very quickly, but you can really sort of, well, there's a lot to learn, but you don't actually need to learn it very quickly, right? You can actually take your time and learn what you need to know as you need to know it. So don't be too intimidated by all of these different menus and drop-down things. Just play around with them and start getting a sense of what you think is fun. So for instance, here in this visibility tab, we have properties like, is this node visible or not, right? You can toggle the visibility of the node by clicking this property. You'll also see that this little eyeball blinks open and shut when I do that. You can also very quickly toggle the visibility of an icon or of a node by clicking the eyeball, okay? You can also change its modulation. Modulation is just like an extra color that's applied on top of the node, okay? So if you want to make this like a red node, you can just drag these sliders around, and now we have a nice red node, okay? But again, it's not actually changing the file, right? The file itself is still blue. You can just imagine like we've sort of put a color on top of the file that is red, like a red piece of plastic or something, okay? I wouldn't worry too much about any of these other ones right now. There's a lot of different properties that you can have. But some really fun ones right out of the gate are position and scale and modulation. Okay, so this is all pretty cool. We have like a little robot in our scene, but like, is this a game? Not really. This is just like an editor, right? How do we actually get a game? How do we run our project now? Well, if we want to run our Godot project, we can look up here to the top right-hand corner, okay? This bar shows you all the different options you have for running scenes. The way to run your whole game is to just click this play button, or to do whatever in the parentheses, right? If you're on Windows, you can press F5. I think if you're on Mac, it's like Command, maybe period, or Command B. It should say so right there. But basically, click this little triangle. And then before we can run it, we get this dialog pop up, right? It says, no main scene has ever been defined. Select one. You can change it later in the project settings under application category. Select current. What does that mean, okay? Like I said earlier, Godot projects are just a bunch of scenes that are combined together, but you always need one main scene that basically acts as the entry point, right? If you're walking into a house, you can't just walk into any random room. You have to walk in through the front door, right? So you can think of your main scene as like the front door to your project. Which thing is going to open up first that's going to launch everything else in your game, okay? So we can select the current scene that we're in, this unsaved scene, to be our main scene. But in order to do that, we have to save the scene, okay? So this is, you'll see right here that we have this save dialog. This is just going to be in the root folder of our project. .tscn stands for text readable scene. It basically is the extension, the file extension that Godot uses to save scenes, okay? And I'm going to call this scene main scene, okay? I'm going to hit save. And a lot of things just happened. For starters, the game launched. That's so exciting. And we'll see that the little icon is now in this window, in our game. That's so cool. If we want to stop our game, you can click the stop sign. Okay, that'll make it disappear. And you'll also see, if we go back to our file browser, you'll see that we have a new scene here, a new thing here called main.tscn, okay? So we have saved our scene, and now when we run our project, every time when we run our project, we have like a project here. We have an actual thing that exists. It's so exciting. Let's take a moment now to, well, I'll also show you, right, if you move around if you make any changes to your project, right? Let's say we move this little icon and grow it, then we can hit play. And it's different now, right? We can move it over here. It's different. It's very exciting, right? We have now a scene that we can modify and change. Okay, so yeah, we have a main scene with an icon in it. That's pretty exciting, but again, you know, it's nothing special. It's not really a game. It also doesn't really meet the Lab 2 or the Lab 1 requirements, right? If we go back to Lab 1, we want to have 2 different sprites and several instances of another scene, and we want it to be in GitHub. Okay, so let's sort of go through and sort of explain some of those criteria and why it's important, okay? For starters, we have this icon here, and that's like an icon that is a sprite, right? We have one image here, but a sprite can be anything, any sort of visual image, right? You can get a JPEG or a PNG, and you can add it as an image to your game. So let's do that now, right? I'm going to go online, and I'm going to search for like I don't know, maybe like a dog. I'll search for a dog, and I'll say dog PNG. Okay, just search for an image online, and what you want, what's really nice about PNG as a file type is that they can be transparent, right? So if you go to color or if you just click on a PNG, right, and it has this sort of checkered background, that shows you that there's actually like a transparent background, right? So you can actually just have this dog as a standalone dog. So I'm going to go ahead and do that. I'm going to add a raw dog, a blank dog. So I'm just going to copy this image, and I'm going to go back to Godot, and I'm going to right-click here and paste. Let's see. I'm going to open up the folder. Nope. I'm going to open up the file manager and just paste this image, right? Or you can also drag and drop an image from the internet, any sort of way you want to put an image in a folder, right? And I'll just call this dog. And then you'll see here in the editor, right, we'll import that PNG, we'll import that picture, right? And again, I hope this is starting to become clear. This area down here, this file system viewer, is just a view of whatever is in your folder here, right? So if you added a new folder, I'll call it like assets, right? You'll see that it gets added here in this view. And if you move things around in this folder, it'll get reflected in here. It's always good to move things around within the editor itself because it'll take care of some behind the scenes stuff. But for instance, right, I just put these pictures inside this folder. And then if I go back to the file browser, we'll see they're no longer here. They're inside this folder. Okay, so I've added a new asset to my project. And what I'll show you first is that you can always change, right? Just like you can change the rotation or the scale of a property, you can also change the texture of a sprite in the same way, right? If I reset it, it's empty. There's now no sprite here. And I can drag this robot onto this property, or I can drag this dog onto this property, right? And now we have this dog, and that is one really big boy. It's a good dog. That's a good boy. But right, what I'm sort of showing you is right, this texture property. This is just another property, just like any else, and you can set it with any image that you want, any sprite or asset, right? And again, PNGs are really nice because they're transparent, right? We have this transparent background. But we want to create two different sprites, right, with two different pictures. So let's go ahead and do that. I already showed you the very easy way to create a new sprite or a new image, an icon node. But I'm going to show you another way to create nodes, right? I'm going to go up into this scene tree view, okay? And this scene view is going to become one of the most important sort of areas for understanding the structure of your scene, right? Because a scene, again, is just a collection of nodes, but more importantly, it's a tree of nodes. So there's always a root node, and there's always children of those root nodes, okay? What does any of that mean? I'll sort of show you. So I'm going to add a new node, and I'm going to click this. I'm going to do that by clicking this plus button. And when I do that, you'll see that there's this whole window that pops up with all these different nodes. That's a lot, right? That's a lot just on the base level. And then if we open up any of these foldy things, we'll see that there's even more. There's like a bajillion nodes in Godot. Don't get overwhelmed. There's a couple sort of things you can think about to help you get started. Okay, for starters, blue nodes are two-dimensional nodes, okay? Red nodes are 3D nodes, and green nodes are for user interface, like menus and buttons and stuff. So for this first half of the semester, you only really want to think about the blue nodes and the green nodes, okay? Don't even worry about the red stuff. Now the node we want, right, we could sort of open this up and sort of look through all of these. We have an animated sprite, we have a camera 2D, we have particles, lines, meshes, all this crazy stuff, right? We have a bunch of stuff. The node we want, as we said earlier, is a sprite 2D. So you could scroll through here and hit create, right? And that would just create a sprite 2D for you. But that's kind of hard to find, right? You can always also just search for it in the search bar. So I'm just going to type in sprite. And you'll see as soon as I get to SP, really if I just type SP, it'll populate, it'll jump to the closest node, and that's sprite 2D. So it's highlighted it. I'm going to hit create. And now I have a new sprite 2D node, okay? And you'll see that the icon is kind of right on top of the dog, right? You'll see there's a plus sign right on the top. You'll also see that you can't actually see anything, right? That's because, again, we don't have any texture properties set for our icon, for our sprite 2D. I'm going to drag this icon.svg. I'm going to drag it over across the screen and up to this property right here. And then you'll see that we have a very tiny little blue robot. I'm going to zoom in a little bit to try and see this robot better. Wow, that's pretty small. Let's make that robot bigger. So I'm going to go to transform, and I'm going to go to scale, and I'm going to increase the scale of the robot to 2 by 2. Okay? I'm going to link the scale, and I'll make it even bigger. Okay? And I'm also going to, I don't want to get confused because icon and sprite 2D aren't very helpful for me in terms of like knowing what's what. So I'm going to rename them. I'm going to call this one robot, and I'm going to call this one dog. Okay? Dog. And you'll see that this robot, right, is currently a child of the dog. What does that mean? Children in Godot, they always inherit properties from their parents. So for instance, if I took this dog and moved it around, you'll see that this robot goes with it, right? If I take this dog and if I take this dog and move it around, the robot comes with it because it's a child of the parent, right? And you can have parents and children as many times as you want in a scene. Okay, you can only have one root node, but you can have as many children as you want. So, for instance, we have one robot here, and I'm going to go ahead and make another robot by duplicating this robot. With Command D is how you duplicate, or Control D. Now we have two robots, right? And these two robots, they're siblings, but they're both children of the dog, right? So if I hid the dog, all the robots would disappear. If I hid one robot, it would disappear, but the other robot and its parent wouldn't, right? Because parents and siblings don't sort of inherit things from their... parents and siblings don't inherit things from a sibling or a child, right? This robot is not really listening to what the other robot's doing. So if I turn this robot off, that one stays there. But if I were to take this node and drag it on top of this robot, now we have a dog who has a robot as a child, who has another robot as a child, right? And so now, if I move this robot, you'll see that that other robot moves, right? And it's moving because this robot is a child to this other robot. And if I move the dog, everybody moves, right? Because the dog is the parent to everyone. So that's a really important thing to start understanding in Godot, that there are these things called parents and children, okay? And a child inherits properties from the parent. It's not just the transformation properties, right? If you scale it, it'll inherit this scale, right? If we make it visible, we already saw that. If we change the color inherits from it. If we rotate, if we sort of squish around or rotate, no, how do we rotate again? Just drag it over here, right? So we can begin to see how the children inherit things from their parents. And this is really helpful for creating more complicated types of things, right? For instance, we have some characters now in this game. That's kind of nice. But what if we wanted to have like a level, right? Some sort of environment for this weird little game of a dog and two robots walking around in the world. Let's put them in a level, right? Let's make maybe something like a tree, right? We'll put a tree behind them. You could just go get a tree off the internet, but I'm going to show you a couple other nodes that are helpful for knowing about. I'm going to create a new node, and I'm going to search for color rect. This is just going to be a colored rectangle, okay? And you'll see it is right here, and you can just kind of drag. Nope. Oh, no, sorry. It's right over here. This dog is so big. You can kind of drag this colored rectangle to be any size you want, right? So this rectangle has a position property. If we go down to transform, you'll see it has these position properties. Okay, it has a bunch of other stuff too because it's technically a user interface node. Don't worry about that. Again, just the thing that we're focusing on right now is the fact that it's a colored rectangle, right? So you can change its size and you can change its color. Okay, so I'm going to make like the trunk of a tree, for instance. Okay, and then I'm also going to make, and I'm going to call this like trunk. Okay. I'm going to duplicate it and call this leaves. And you'll see that we have two brown rectangles now, right? But leaves are typically green, so I'm going to make it green, and I'm going to make it sort of leaf-sized. Okay, and this is a very ugly tree, but I'm doing this just as an example, right? And currently, right, it's not very helpful to be able to have leaves that are separate from a tree, right? But if I wanted to make one whole tree that I could move around on its own, you would want to have a parent that would have both of these things. So I'm going to create that. I'm going to create a new node, And I'm just going to create a very basic node called a node 2D. This is one of the most basic nodes we have. A node 2D, you can think of it as just like a dot. It's just a point in space. Okay, and it got added as a child of the trunk. I kind of want that to be the other way around, so I'm going to drag it out to the middle. I'm going to take these trunk and leaves and drag them on top of the node, and now you'll see I can rename it, and we have this tree, which has this 2D position, right? Whoops. Which I can then drag. You can click on this wonderful little move mode, which helps you move objects around. And as I'm dragging around my tree node, the trunk and the leaves follow, okay? That's really helpful, right? Because we don't always want to sort of, if we want to make a game, we don't want to have to move, if we need to like add a tree or move a tree around, we don't want to just like, you know, have to move our leaves and our trunk at the same time, right? So that's a very helpful way to sort of create a structure, right? To create a little thing that is like a component that we can use, right? And you can even sort of hide the children of a node by clicking this toggle, so you can start to sort of imagine different ways of creating things. Okay, I'm going to just clean this up a little bit. I'm going to maybe add this robot like directly here. So now we have this like weird little thing where we have like a dog, right? And this dog and these robots are gonna, maybe this is a game where I want them to ride through a forest, right? Well, if I start this right now, we only have one tree, right? A tree is not a forest, so let's go ahead and make a forest, right? Now, if we wanted to make a forest, right, if we want to reuse something over and over again, we could just copy and paste it. So we could just take this node, right, and you can do Command D or Control D to duplicate. What's nice about that is it automatically duplicates any children of the node. And so you can move it over, and we do now have two trees. That's kind of helpful. But what's not great about this system is let's say we're making a game about a dog and a robot walking through a forest, and we think that it wants to take place in spring, so we make these sort of green trees, but then we sort of show it to our friends, and we're like, you know what, maybe we actually think it wants to take place in fall, right? So maybe the leaves need to be brown, right? In order to change that, I would have to go into this leaf and change this to brown, right? But then I'd have to do that for every single one of these leaves, which is sort of a pain in the neck, right? We don't want to have to, if we have like one object that we want to reuse over and over again, we don't want to have to manually change things every single time, right? Or you could think, for instance, if you have like an enemy, like a Goomba in your game, you know, you don't want to have to change the speed of every single Goomba. This is where the concept of a nested scene or creating a separate scene is really, really helpful, okay? Again, Godot projects are actually not just composed of one scene, right? We only have one scene right now. Typically, you make a project with many scenes working together, and I'll show you how that works. So what I'm going to do is I'm going to click on this node, then I'm going to right-click on it, and we have all this sort of context menu pop up, and I'm going to go and click Save Branch as Scene, okay? And it's going to pull up this pop-up menu, and it's smart enough to take the name of the node and put it into the file naming dialog. And I think that's actually a really good name for this scene, because this scene is just going to be the tree scene. And you can think of a scene as like really anything. You can have a scene be a character or an object, and be a weapon or a level or a tree, right? And you'll see a couple of things have happened. Firstly, we've created a new scene file here in our file dialog. Also, the nodes that were once children of this tree seem to have disappeared, and we have this little movie icon. What does all that mean? We've basically taken the children and we've put it into a separate scene file. So if we double-click on this movie icon, we'll open just this scene, okay? And we'll see that our tree is like way over here. Okay, our tree is way over here probably because of the way we created it originally. Don't worry about that too much. What you kind of want to do is bring it back to the middle. And let's just change the scale to smaller, right? Let's make it like 0.5 or something, okay? And then I'll save that, okay? And now when we go back to our main scene, you'll see that it updated the position of our tree, right? It updated it, right? And what's really nice about this is any updates we make to a scene will automatically get transferred to any other places where we're using that scene, right? You can kind of think of this as like a reference. This is like a link to your scene. So it's just going to go look up what's in that existing scene file and load it in at the time that it needs it. So if I want to make this tree, if I want to make these leaves like green or brown, for instance, I can just change it here and hit save. And then back here, bang, I've got a brown tree. And what's cool about this, right, if I duplicate this, if I have like 5 trees and drag them all around, 1, 2, 3, 4, and hello, 5. Now if I go back to the scene, and I change anything, right? Let's maybe some blue leaves because we're on an alien forest or something. Now if I go back to the main scene, every tree has blue leaves, right? Or if I wanted to maybe make the trunk smaller, boop, save that. Now we have 5 blue bushes, right? So scenes, having nested scenes inside of your main scene is really, really, really important in Godot, okay? And that's why it's one of these key components of this lab, right? And so if we go back to the lab assignment, you know, this dog. No, if we go back to the lab assignment, we want to have a main scene, 2 different sprites or images, and several instances of another scene, okay? So we have that now, right? We have a couple sprites and this scene that is instanced several times, right? That's what we call it when we have a reference to a scene inside of another scene. So that all looks pretty good. We can save this project and run it. And there we go. Now we have this sort of dog in a forest, okay? And that's like a lot, right? I know we just covered a lot really, really quickly, and it might be really technical and wonky. I hope that by making this a video, you can at the very least go back and sort of replay any parts that were confusing. I also hope that if you are confused still, you can contact me, right? Please email me at my email address in the syllabus. Ask me questions in class. We're going to be going over this stuff for the rest of the semester, so I know I've sort of thrown a lot of concepts at you pretty quickly, but hopefully through practice and repetition, they can become a little bit more familiar, right? Godot can be pretty overwhelming at first, but once you sort of understand a couple of these core components, like this idea of having scenes and nodes and trees of nodes and nested scenes, you can really start to create some really wonderful, interesting projects, okay? So digest all of this, try and use this to help complete your lab assignment. Again, the first lab should be due about a week and a half from today, so it should be due around Monday or Tuesday the whatever, the 10th of October. You can take your time on this one, but just do it to the best of your ability, follow along, and I'll put this up on the syllabus on the website, and you can use this as a reference, okay? The last thing you need to do, right, in order to actually submit your project is just go to GitHub, right, and you'll see now in GitHub that you have all these updates. So you just want to write a summary, like created dog in forest, and then hit commit to main and push to origin, okay? And now if we go on to GitHub, on the website, you'll see that here is your project with lab 1, and here is the project, right? Here's our tree scene, here's our main scene, and here's our dog and our icon, okay? So that should be how you do everything you need to do the lab, right? That's how you can create a project, push it to GitHub, and then in order to turn this in, again, all you need to do is take this URL and submit it on Blackboard or Canvas, okay? So thank you so much. Thanks for sticking with this one, and reach out if you have any questions. Have a great weekend, and I will see you in class the next time we meet.